All right, hello everyone. I wanted to take a second to show you how to use the Monte Carlo code for doing second checks for electron Monte Carlo. As you can see, I'm in my program directory, and there's a listing for the PyOpenCL.py. I have downloaded this from GitHub, and I have Anaconda installed. You can see I'm in Windows Terminal, and I'm inside of an Anaconda prompt. So I'm going to start the program by typing Python PyOpenCL, enter, and that should take a second to build the program. If it's the first time you launch it, it'll take a lot longer, just because it's building the underlying structures in the background. So the first thing you want to do is just open a directory that has the DICOM files in it. And I've got two sample directories. I'll show you both of these while we're on this video. The first one is a Phantom that I scanned, which is a cryovac pack of pork ribs inside of a water bath sitting on top of a piece of plastic water. I scanned this as one of the things I used when I was trying to commission electron Monte Carlo. And you just see these different structures: body 7001, 7002, and old chamber. These are just CC13 chambers that I taped or mounted somehow inside of the Phantom here, just for doing testing. So there are a few options that you can change just in the basic settings. The plan data shows up over here in the plan table, and then a calculation grid size right now is set to 2 millimeters, and the number of particles per cell is set to 500. I'm not going to go very high in terms of the number of particles per cell because I'm using a laptop with a pretty small graphics card. If you wanted to change them, you would just go up and down here, and then you can say 1 millimeter grid size and 1500 particles per cell. The smaller the grid size, the higher resolution you're going to be, and the number of particles per cell, the less deviations you're going to see inside, or smoother lines you're going to have, I guess you should say it that way. So when you're all set to go, you just hit calc, and it'll run through the calculation. And now you can see that I've got a calculated dose distribution that will compare with the electron Monte Carlo or the treatment planning system. In this case, my treatment planning system is Eclipse. So the view automatically zooms to where the ISO center is, which is represented by this orange line, and the reference point, which is represented by this blue diamond. There's a visualization of the cone here in these yellow X marks. And if you have a very complicated block, in this case I just have 4 points for the block, so you don't see it on here. But if you had a more complicated block, you would see red lines indicating where the distance of the block is. Now that the calc is done, we have a calc mu and a percent difference. I'm going to show you a couple more calcs so you can see how this changes. And you can see that with only 500 particles per cell, I'm going to get a lot of deviations. I can up this to 200, 2000. I won't do it very many times because it just takes a while. And you'll see it looks like it's hanging there, but it's not really. It's just running in the background. I haven't put any kind of async await logic into this program yet. But now you can see that with 2000 particles, my percent difference has gone down a lot. I can calc this a few times at 2000. And you'll see that it's going to eventually close in on where it should be. So this is just one example I'll show you the other example in a second, but I wanted to explain one thing. The tools here right now, when you zoom in and you try to scroll, you'll eventually go back to the original view. And that's something with the plotting library I'm using. I have to figure out how to change it in this version. In my initial version, it would let you stay in the scrolled, it will let you scroll in the zoomed position. I'm not sure why it's not doing it here. I've tried to mimic the same setup. When I figure that out, I will add that to the code. The other thing I wanted to point out before I go to the next view or the next patient is every now and then you'll see a title that says no calc dose on slice. This is just an interpolation of the calculated dose to the visualization. I don't always have anything, and so I don't want to fake it out, so to say. So I'm just saying there's no calc dose on this slice. It doesn't affect the actual calculation or the MU that you get out because it's looking at that same point all the time. So let me open up another one. This is a phantom patient that I made. And the reason I wanted to show you this one, excuse me, is because this is the one you would use for setting up the calculation to your clinic site. So this is just a water phantom that I drew inside of Eclipse. And you can see now I've got in this bottom window, this bottom list, the structures that you want to override. What this does is adds it takes a while to do this. Don't think it's locked up or anything. What this does is overrides the density value from the DICOM file. The initial structure set just is empty and has a DICOM value of -1,000. I mean, a HU value of -1,000. To actually make this act like water, you have to override the density. So that's what this means. This is actually based off of a matrix phantom that I made. So there's wood on either side that holds it all in place. And so you can see if I add these structures, they show up as well. So any kind of bolus that you might have or scar wire, you would have to override those here if you have the density overridden in the treatment planning system. You can also take these off again if you want. It takes a minute to run, but it's not instantaneous by any means, so just be aware of that. And you might get the hang up and it'll say not responding at the top window. It is doing something. Like I said, there's just no async await kind of logic in here yet. So now that I've got my plastic water density overridden, I'm just going to do a calculation. And you'll see this is what, oh, sorry, I hit the wrong button. Come back to that. So we're just going to do a calculation. And you'll see this is what the calculated dose looks like versus what the Eclipse dose was like. The higher resolution I use and the higher number of particles, the smoother this is going to end up being. There is a way to calibrate this, and in a future video I'll talk about that. Right now I just wanted to show, basic functionality of the program. And you see it says not responding there. It really is doing something in the background. Just give it a second. If you are on a higher resolution or a higher powered machine, this doesn't take as long. I have an Eclipse machine with one of the P5000s, and it works a lot faster than this. So now you can see with this higher resolution at 1 millimeter and 4,000 particles per cell, I'm getting pretty smooth lines, and they are matching what the Eclipse dose was rather well. And you can see my calculated MU is very close now to what the treatment planning system gave. I'll come back to this ref dose 30. That's actually how you calibrate what your MU are going to be based on the numbers you get. So one last thing I wanted to show you. I'm going to go back to the home position here. You have a save button. So if you want to, you can hit save and it'll open up a web page that includes the patient's name, the plan name, their ID, a little bit of the details about the calculation, like the radiation, the cone, the energy, and then it'll tell you what the second check MU were and the treatment planning system MU. Looks like I need to format these a little better, and then you have a percent difference. So you can then print this if you wanted to, or putting it into a chart by right-clicking and hitting print. And I usually just hit save as PDF. And this is what it would look like that you would put into your chart. You can always sign it here with Adobe or something. All right, that's all for now. If you have any questions, please let me know. Thank you.